This will be about operations with radicals. So in the first part, we're just going to do a little bit of a warm-up and express these radicals in simplest form. So we're going to be looking at mixed and entire radicals. So presently, we're looking at the root of 12. Index is 2. It's just not shown. There is a little invisible 2 there. So to work with this, there's a couple different ways you can approach. You can break 12 down into prime factors, or you can look for perfect squares. Okay, so I think that we'll do one of the methods with root 12 and the other method with root 32. Okay, so let's just start here. We'll pick prime factors for root 12. So 12, we'll just do a ladder. If we take that, divide it by 2, we get 6. Divide by 2 again, we get 3. 3 is a prime factor, can't break it down any further. So these are your prime factors of 12. 3 times 2 times 2. That brings you back to 12. So we're looking at prime factors of 12 presently. And because we have a square root, we're going to want to arrange these so that you have a square. So let's just write out what we've got first. 2 times 2 times 3. That's all underneath your root. And we'll organize it so that there's a square because we're dealing with a square root. So 2 squared times 3. And what we're really looking at when we do this is root of 2 squared times the root of 3. And that's a square root. So when we take the square root of a square, you're left with the number underneath the root. In this case, 2. So some like to cancel, some like to do this using exponent laws. I'll just do it by canceling for the sake of this. So we're looking at the square root signing, canceling the square. So we're left with 2 times root 3. You don't need to put the multiplication sign there. 2 root 3. So this is an exact number. Moving to root 32. So for this one, let's do a different method. Here we broke our factors of 12 down into the prime factors. Over here, we're going to organize it into perfect squares. So to do that, we need to know the factors of 32. So if we're looking at 32, 1 times 32, 2 by 16. It's not divisible by 3. 3 plus 2 is 5. We know that 5 is not divisible by 3. And then we just keep going. Okay, so divide by 4, and not 5, 6, 7, etc. So we can actually stop right now because I do see a perfect square in here. I see 16. Okay, so we're going to take 16 and its pair, 2. So we're going to organize root 32 as root 16 times 2. Okay, and then we're going to go from there and just break it down a little further. So what we're actually looking at is 4 squared times 2. And now we're back to that square root of a square scenario. And we're multiplying by, don't forget, the square root of 2 as well. So the square root of a square leaves you with 4. It's like going 16 squared, which is 4. So we're just left with 4 times root 2. This is just root 2. Okay, so we're sitting at 4 root 2 as an exact answer. Moving to mixed and entire radicals. So we want to check out a little more, and in this case, we have a cubic root. So we're going to do, again, 2 different methods, prime factorization or the perfect cube method. So for this one, let's do prime factorization again. So we're going to take 24, and we're just going to use the ladder method to break this down. So divide by 2, so we get to 12. Divide by 2 again, 6. and divide by 2 again, 3. So let's just check it. 2 times 2 times 2 times 3 is 24. Perfect. So we've got our prime factors. Keeping in mind this is now an index of 3. So you can actually see the number there. We're taking a cubic root. So the index in this case is 3. So we're going to organize this as the cubic root. Oops. A little bit messy there. So we're going to go cubic root of 2 times 2 times 3. Oops, 2 times 2 times 2 times 3. All underneath that cubic root. And then we'll make this a little more condensed. So it's 2 cubed times 3. Okay, so what we're dealing with now is an index of 3 and a cubic root. Perfect, that's what we want. So the cubic root of 2 cubed, I think you know what's going to happen with that, multiplied by the cubic root of 3. We have a cubic root with a cube. Those will cancel, leaving what's underneath the root, in this case 2, times cubic root of 3. Okay, so here we have a exact answer. 2 times the cubic root of 3. Let's go over to the cubic root of 32. So in this case, let's do perfect cubes. So we're going to think about excuse me, factors of 32 that can be perfect cubes. So again, we just write down some of the factors of 32. 1 by 32, 2 by 16, 4 by 8, and we hadn't got to a perfect cube until now. There's an 8. That's a perfect cube. 2 by 2 by 2 is 8. So we're going to use that. So we're going to go cubic root of 8 times 4. Front number, in this case 8, is the one that's going to be the perfect cube. So we're going to break this down as cubic root of 2 cubed times 4. And that will give us 3 as an index, and the cubic root of 2 cubed times the cubic root of 4. And this will simplify down. The cubic root again will cancel the cube, leaving 2 times cubic root of 4. Okay, so that would be the exact answer, 2 times the cubic root of 4. And you can put that in your calculator and just check what it would be as a decimal. Okay, so moving to expressing mixed as entire radicals. So we're just going to move from 10 root 2, keeping in mind the index on this one. You don't see it again, but there's a 2 there. So technically that 10 got out because it was square rooted. It used to be under the root, and we square rooted it to get out there. So that means there used to be 100 underneath the root sign. So let's just go through and show that. Okay, so this technically would have looked like 10 squared times 2. We'll just condense the work a little bit there. So that's going to be your 100 times 2. So then your radical would have looked like that, root 200. Over here, we're dealing with a negative in front of the root, so we've got negative 4. Okay, so when we deal with that, we are just going to leave the negative in front, and we're going to take that square root again. Remember, it's an index of 2. That's why we're going to square the 4. We still have that 3, so multiplying by 3 underneath, leaving you a negative 16 times 3, and a negative root 48. Okay, so that is the negative staying down with it. Moving to the next one, we have 3, and then there's a cubic root of 2. So that means there was a number that was cubic rooted to get to 3. So we know that that number will be 27 when we get to it. Okay, so when we actually get down to that one, let's show that. Okay, so then from here, it's going to be cubic root of this 3 underneath cubed. That's how we got 3 outside. We took the cubic root of 3 cubed. But don't forget, there's still a 2 underneath that root sign. Okay, so now it's the cubic root of 3 times 3 times 3, which is 27 times 2, leaving you the cubic root of 54. Okay, so moving to adding and subtracting radicals. So the key point here, when you're looking at adding and subtracting, you can only do this if they have the same root index and the same radicand. So the radicand is the number underneath the root sign. So in this case, we call those like radicals. So to do that, we just check out what we're dealing with in this case. There's a 2 square root 3 combined with 5 square root 3. Okay, this one's not too bad. They have the same index, 2, and the radicand is 3. So we can simply add the numbers in front. Okay, so we're just going to take 2 plus the 5, which was 7, square root 3. It is that simple for this one. Okay, for this one over here, same kind of thoughts, but this one is a little bit more in depth. There's a little more work to this one. Okay, so we want to think, okay, well, I see a square root, square root, square root, square root. Perfect. But the radicands don't look the same. So we need a little work on this one. We're going to have to break this one down to see if we can get similar radicands and then combine those terms as like terms. Okay, so what we're going to do is just start with the original. So 3 root 24, and we're just going to break this down to perfect squares times the factors. So what I mean by that is 3 times factors of 24, 4 times 6. So root 4 times root 6. So that's what we're dealing with here. Let's just move this over. So we're dealing with 3 times root 4, root 6. Then from there, we have a negative 2 root 54. So we have negative 2 times, let's do some square roots. Pick perfect squares in this case, again, because the index is 2. So factors of 54, 9 times 6. So we're going to go root 9 times root 6. That's root 54. Perfect. Our goal by doing this is to see if we can get the same radicand. So far, there will be a couple with root 6. We'll just keep working and see if that's the case with the next 2. So plus 3 times factors of 28, in this case 4 by 7. So root 4 by root 7. So this one you can see will not be able to combine with the others. Let's finish it up. Minus 75. So perfect squares, 25 times 3. What are the factors? So it's root 25 times root 3. Let's just go through and simplify some of this. Okay, so we had technically a 3 times root 4, which is 2. All that root 6 minus 2 times root 9, which is 3, times root 6, plus 3 times root 4, which is 2, root 7, minus, square root of 25, 5, root 3. Okay, and then we'll just simplify this down a little bit, 2 by 3, minus 2 by 3 again, plus 3 by 2, that was a 7 under the root there, minus 5 root 3. Okay, and then we combine any like terms that we have here. So we'll just take a quick look and see what are we dealing with. Okay, well, this is a positive 6 root 6. This is a negative 6 root 6. So these form 0 pairs. So all you're left with is 6 root 7 minus 5 root 3. We don't add or subtract these. They don't have the same radicand. They do have the same index of root 2, but the 3 and the 7 are different radicands, so we don't combine those. Okay, moving to the next part here. Multiplying and dividing radicals. Okay, so when we do multiplying and dividing radicals, we're just going to keep in mind a couple key points here. Multiplying radicals follow the rules. Multiply the number by the number and the radical by the radical. Okay, when you divide, you're going to follow similar rules. Divide the number by the number and the radical by the radical. Okay, so when we do that, let's just draw up a quick one here. We're going to look at 2 minus root 6 multiplied by 3 plus root 6. And our goal will be to figure out, what does this equal? Okay, so we're just going to multiply, as the points are said, number by number, radical by radical. Okay, so in this case, we're going to take the 2 minus root 6 and multiply it by the 3 plus root 6. So we're going to go 2 by 3. 2 times 3, we get 6. And then we're going to take 2 times root 6. So this is a positive 2 root 6. And then we have a negative times 3 root 6. So that's a negative 3 root 6. And then the last one, negative root 6 times root 6. So we have a negative times a positive, which will just leave you as a negative. And then it's root 6 times 6, which is 36. Okay, and then we just do any simplification that we can do from here. So technically, I see a plus 2 root 6 and a negative 3 root 6. So these are like radicals. We're going to combine them. So it's negative 3 plus 2, which leaves you with negative root 6. And then I look at square root of 36, which is 6, and a positive 6. So these two actually cancel each other out, leaving your answer as negative root 6. And that's it for that one. Okay. So from there, let's do, I'll just copy my title here. Let's do another one. So we're going to do one where you're dividing. Okay, so if we're just dividing, let's do one with root 21 over root 3. Oops. All right, so from here, you can write this whole thing as a root. 21 over 3, which equals to root 7. Okay, that's one of the simpler ones. Let's take another look at a different one. Let's do square root of 150 over the square root of 3. Okay, so from here, you can go ahead and skip that step of putting it under the whole root and just go 150 divided by 3, which is still the square root, but now it's just 50. And 50, we know there's a perfect square in there. Factors of 50, 2 times 25. So we're going to break this down to have a perfect square. So square root of 25 times square root of 2. And we'll just take the square root of 25, which is 5, and leave the root 2 there. Okay, so that's been broken down and simplified as far as it can go. And this was dividing some radicals. Okay, moving on to rationalizing. So it's going to look like division. There's going to be some elements there, but we want to keep in mind what the word rationalize means. This means to make the denominator a rational number or remove the radical from the denominator. So we don't want that root down there. Okay, so to be able to get the root out of there and have the denominator rationalized, we're going to take top and bottom of the original item, in this case 1 over root 7, and we are going to multiply top and bottom by the root 7. Okay, and when you do that, you just have 1 times root 7, which is just root 7, over root 7 times root 7, which we've already covered when we do some multiplication. 7 times 7, we know is 49. And then we can just break this down just a little bit more. So root 7 over the square root of 49 is 7. So we've got that one there. Okay, and then another one with a little more work to it. Okay, so we have root 8 divided by 3 times root 6. So in this case, the root 6 is what we're trying to get out of it. We want to rationalize the denominator. So in this case, we'll just take the original, root 8, over 3 times root 6. And we are going to multiply again the whole thing by the root. So in this case, root 6 plus root 6. So we're multiplying top and bottom, so we're not changing any values. Just the way this looks. So what we've got is root times root. So we have 8 times 6, which is 48. So the root of 48 over, in this case, 3 times root 6 times root 6. So what we're really left with is 3 times the root 6 times root 6, which is 36. So that's what we're looking at, and then we'll simplify this a little further. I think we'll do that at the same time. So the top, we're going to create a perfect square times the other factor that gave you 48. So 16 being the perfect square times 3 is 48 over 3 times the square root of 36. We know that's 6. So 3 times 6. So we're left with 4 outside the root, because we're going to take the square root of 16. So it's going to be 4 root 3 over 18. And then we're going to divide top and bottom by factors that are in common of 4 and 18. In this case, 2. So just divide top and bottom by 2. So this is 2 root 3 all over 9. Okay, from there, let's go for a little more. Conjugates. So when we're dealing with conjugates, just read the title at the top there. These are 2 binomials that are identical except for the middle sign. Okay, so we're just going to have a quick look at one of those examples here. So when we talk about the middle sign, we're talking about, here you see a plus, and here's a minus. Otherwise, they're exactly the same. So we're going to be multiplying. And when we do that, remember to multiply the numbers by the numbers and the roots by the roots, just like we talked about with multiplying previously. Okay, so to do this, we're just going to take your original. And one thing before I continue here. The nice thing about this is you are going to eliminate some terms as you go due to the fact that you have opposite signs. So you're going to create some zero pairs. Okay, so let's just start by working on this bracket here. So first term times the first term in the next bracket. So we're just distributing, or foiling as some people like to say. So if I'm actually going to use that word FOIL, we can just keep in mind what it means. Okay, so when we actually multiply out these radicals, what it means is first term, outside term, inside term, and last term. Okay, so that's what we're doing here. So this is first. Okay, then we'll just continue and do outside. This will be inside and last. Okay, so just we have an order to follow here. So we're going 2 times 2, which is 4, and root 7 times root 7. I'll just write it out for what it looks like first, root 49. Then we're going to go 2 times a negative 3, which is negative 6. And then again, we have a root times a root. They're the same index, therefore we can multiply through. So we're going to go square root of 7 times 3. Okay, so that takes care of the first and the outside. Let's do the inside. It's a positive times a positive. It's a positive. So 3 times 2, 6. Root 3 times root 7. All right, so there's that root. 21 again. And last, negative times a positive. So negative 3 times 3, 9. Root 3 times root 3. So we're just going to show that as root 9. And we'll simplify after. Okay, so what am I seeing so far? I'm seeing 4 times square root of 49, so 7. I see a negative 6 root 21, but here's the opposite. So the zero pair, positive 6 root 21. These ones cancel out, leaving negative 9 times root 9. So that's 3 times negative 9. Okay, so we're going to subtract. Let's just do it all. I'll make it look the same as this one. So 9 times 3. So the square root of 9 is 3. So this is just 28 minus 27. And that equals 1. Okay, so all of that work came down the coefficient of 1.